Hello, my dear friends. I am Dr. Gayal Baliram Sambhaji, working as an assistant professor in the Department of Electronics and Telecommunication Engineering, RMD Singer School of Engineering, Pune. Today's our topic of discussion is digital logic family. Now, what is meant by logic family? A group of compatible ICs with the same logic levels, it may be low or high, and supply voltages for performing various logic functions have been fabricated using a specific circuit configuration which is referred to as a logic family. Logic family is a circuit configuration used to produce a type of digital integrated circuit. Digital integrated circuit means that is a we commonly call as a IC. The entire range of digital ICs are fabricated using either bipolar devices or unipolar devices or combination of these both bipolar and unipolar devices. Now broadly we can classify logic families that digital ICs as bipolar and unipolar. Again, these bipolar are classified as saturated and unsaturated. And this unipolar is classified again in three types. Now, this bipolar, this is a saturated having types resistor transistor logic, that is RTL, diode transistor logic, that is a DTL, then direct coupled logic, that is DCTL, then integrated injection logic, that is SQL, and high threshold logic, HTL, and transistor logic. Here, in the out of this, that DCL and this TTL are the most common. And under this bipolar, there is an unsaturated type, and under that, again, this unsaturated is classified into two categories. That is Schottky transistor logic and emitter coupled logic. While this unipolar is classified into three categories, that is PMOS, that is a P-channel metal oxide field effect transistor, NMOS, that is the N-channel metal oxide field effect transistor, and CMOS, that is a complementary MOSFET, that is a metal oxide field effect transistor. Then this bipolar logic families, these are the mainly classified, which we already discussed, that is saturated, unsaturated, and that having different types. Then unipolar logic families, these are the metal oxide semiconductor devices that are the unipolar devices, and only MOSFET are employed in MOS logic circuits. The MOS logic families are PMOS, NMOS, and complementary metal oxide field effect transistor. Means that is a combination of this. While in PMOS, only P-channel MOSFETs are used, and in NMOS, only N-channel MOSFETs are used. In complementary MOS and CMOS, both P-channel and N-channel MOSFETs are employed and are fabricated on the same silicon chip. Now, this logical family commonly used as TTL, that is a transistor logic. Then this is a standard logic family used for the longest time. Then ECL, that is a emitter coupled logic. It is suitable for the system requiring high speed operation. Then MOS, that is a metal oxide semiconductor logic. This is suitable for system with high component density. Then CMOS, that is a complementary metal oxide semiconductor logic. This CMOS logical family is suitable for system with low power consumption, such as VLSI circuit. Then gradually it becomes dominant logic family in that electronics field. Now we consider that TTL logic family. First, this is introduced in 1964 by the Texas Instruments. That TTL has shaped digital technology in many ways. One of the most widely used family for small and medium scale devices, rarely used for VLSI. Standard TTL family, example, we can consider that 7400 now becomes absolute. That newer transistor logic family still used, that is a 74ALS00. That is a high energy consumption, but relatively insensitive to electrostatic discharge and distinct, that having distinct feature. In this diagram shown that internal structure of that TTL logic family, that having transistors, okay, likewise structures, that diode and resistances. Now, there are three commonly used families of digital ICs, as we discussed, that is TTL, CMOS, and ECL. Again, here, when we consider that IC structure, that physical IC, it having, for example, this is a 7400 IC. Here, this is a SN is a suffix, and while N is a that SN we call as a prefix, and N is a suffix. Now, here, what it denotes, that S denotes that manufacturer, Signet, then DM, National Semiconductor, and this SN denotes Texas Instruments. While this suffix, okay, this N denotes the plastic dual inline deep structure, then W ceramical flat pack, and D surface mounted SOP plastic packages. And again, we are having 7.4 series, which are used for military versions, and 7.4 XX commercial version, that having temperature range of 0 to 70 degrees Celsius. Now, when we consider this transistor logic, that is 7.4 series code, that having this here, having prefix here, we called that is that when it having CD, that it means that RCA, then DM is National Semiconductor, MC means Motorola, MM means National Semiconductor, N is Signet, PC is again Signet, and SN is Texas Instruments. And while this suffix N, we already discussed plastic dual inline package, P denotes 8-pin plastic DIL package, and J is a ceramic package. Now this evolution of this transistor logic family. Oldest is a 7.4 series, that is a constructed using bipolar transistor, that are the saturated BJTs and practically absolute. Don't use nowadays it is. Then 7.4S series. Then after that 7.4LS series. Again, it is using bipolar, lower power, slower speed, and version of the 7.4S series. Then from the 7.4S series, there is a 7.4AS series, that are the innovations in IC design and fabrication. While from the 7.4LS, we are having another evolution, that is 7.4ALS series, that is innovation in IC design and fabrication, improvement in speed and power dissipation popularly. Then next version is 7.4F series, that is innovation in IC design and fabrication used for fabrication popular. Now this also we discuss on that IC here, that TTL, that is a standard transistor logic. An example for this is 7400. When it having L means that is a low power TTL, that is 74L here denoted L, that is 0. Then H means high speed TTL, 74H denoted here. Then S, that is Schottky TTL high speed. This L, yes, means low power Schottky. This is AS, that is advanced Schottky. Then AL, yes, that is advanced low power Schottky. And this F, that is a fast Schottky. Now, that is a CMOS, complementary metal oxide field effect transistors family. This considerably lower, it consumes low energy than TTL and ECL, which has made portable electronics possible. Most widely used family for large scale devices, combines high speed with low power consumption, usually operates from a single supply of 5 to 15 volts. Excellent noise immunity of about 30% of supply voltage can be connected to a large number of gates, about 50. Don't leave input floating, susceptible to electrostatic damage. In TTL, this will float to a high HI in CMOS. You get undefined behavior. Now that evolution of the CMOS families, starting is a 4000 means that is 4000 series. That is a CMOS, wide support voltage range, high noise margin, low speed, weak output. These are the characteristics. Then next series is 74C series. That is a pin compatible with TTL devices, low speed. Now today it becomes absolute. Then next series evolved from that 74HC or SCT series. Uh, then 74AC ACT series. The next 74 ACHT series, there is a CMOS improved speed and again lower power consumption, lower driver capacity. Then by CMOS logic, then 74 LVC, ALVC, LV. That CMOS reduced supply voltage here. LVC is a 5 volt to 3.3 volt, and here optimized for 2.5 volt and down to 1.2 volt. This is a physical appearance of that IC is shown here. Now, power reduction is one of the key to progressive growth of integration for this CMOS logic families. Now here, that TTL and CMOS subfamilies we already discussed and we summarize. The TTL low power, their letter denotes L, high speed means H, that S letter means Schottky, LS means low power Schottky, AS means advanced Schottky, ALS means advanced low power Schottky. These are the subfamilies of this TTL logic families. Then for CMOS, HC means high speed, AC means advanced. That are the subfamilies of complementary metal oxide field effect transistors. Now, these are the few references I referred for this. Uh, Textbooks, reference books, then MOOC, NPTEL courses, then virtual labs. Okay. Uh, Thank you.